T-minus 1 minute. T-minus 30 seconds. We are go for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Next up for NASA Social, we're going inside the hangar at 39A.
Hello and welcome to NASA's Virtual Social. My name is Philip Hargrove and I'm coming to you live at the Kennedy Space Center Visitor Center right in front of the beautiful Atlantis Space Shuttle. It's been a few days, but this just never gets old, does it? I'm joined by Stephanie. How are you doing today?
I'm doing well, Philip. How are you?
Doing great, doing great.
Awesome. Hey everyone, I'm Stephanie Plusinski with NASA Communications. And did you know that the worm is back? In fact, we're going to take you into the hangar over at Launch Complex 39A to check out the rocket that'll send Americans from U.S. soil to space for the first time since 2011. As always, if you have any questions, feel free to leave it in the comments section below, and we may just answer it live.
All right, so as Stephanie said, we really want y'all to, engage in this discussion. We're going to start off with a really interesting video of a tour that we took onto Pad 39A and into the hangar. So basically the place where everything happens before the vehicle and the spacecraft are ready to get up there into space. So one thing is that, hey, this is Kennedy Space Center where, everything happens. We launch from here. It's a very dynamic place. So what that means is that it can be pretty loud sometimes. So the audio is a little rough, so we do have captions on the video, so just be aware of that when you're watching the video. So we hope you enjoy it, and we will be back in just a few minutes to talk about it.
We're here at the historic Launch Complex 39A at the Kennedy Space Center to learn more from Kiko with SpaceX about launching humans into space. So I know last time we met here, you were focused on the Dragon specifically. Is that still the case?
Yeah, so I'm the director here of the Dragon Ground Operations Group. My team is responsible and accountable for all of the vehicle processing we do on the spacecraft as we get ready for launch, and also maintaining it, refurbishing it after it comes home from a successful launch. We also handle all of the crew operations that we do at the Cape, and also actually do the launching of the spacecraft itself. We work very closely with the booster team to really form this integrated SpaceX team, and then obviously every day we're working side by side with NASA to ensure a successful and reliable flight. We're really excited to do something that is going to not only accomplish this goal for both NASA and SpaceX, but inspire the public and get people excited about the International Space Station, and really hopefully get that next generation pretty inspired to do their own great things.
Yeah, and obviously space hardware is a big part of that. Let's take a closer look. Awesome. So Kiko, from the outside, this facility looks pretty unassuming. Walk in, and obviously this is not a normal space here. So what are we looking at here? What's this facility for? How does it get used in the process of launching into space?
Yeah, so welcome to the hangar at 39A. It's roughly 54,000 square feet. It's the size of a football field with the end zones on the inside. It's mainly used for processing Falcon 9 in preparation for flight and also doing maintenance on certain boosters that have already flown.
Okay.
So this hangar can actually fit 5 boosters, 5 Falcon 9 first stages, side by side, and it's effectively the place where we go through all the last little bit of processing before we take a rocket and spacecraft out to the launch pad. So, for example, Dragon will actually arrive on the doors over basically at the front end of the rocket.
Okay.
We'll use both cranes to flip it or break it over horizontally. We'll mate it onto Falcon 9, and then using the big white transporter erector that you see out on the pad, we actually just open these big doors up in the hangar and roll the rocket up the hill, up to the actual pad. NASA's helped set the framework for what needs to be done and kind of help build off of all of the lessons we've learned over the 50 years of spaceflight, 60 plus years of spaceflight that we've had, but sort of given private industry the keys to figuring out how to go get it. And it's been amazing to work with my partners at NASA. Some of the people I've personally been working on the program for 8 plus years, and what's interesting is this is really kind of the start, right?
Exactly.
It's finishing
As long
one
as it's
phase.
finished, it's the start.
Yeah, it's finishing one phase, but it's really ushering in a whole new era where America has able to actually get astronauts to space on an American-built vehicle from ground soil.
Yeah.
And it hopefully brings on a whole new era for the International Space Station, whether it be our standard rotation of astronauts or possible commercial ventures that are being worked through.
Can you tell me about Dragon 1 versus Dragon 2 and Crew Dragon?
So Dragon 1 was the vehicle we just retired that just had its last mission. First flew in 2010, first went to the space station in 2012, and then just finished up its last mission here in April of 2020. I always knew we were going to go build a vehicle to fly humans.
Sure.
But there were a couple key upgrades we had to make. The first one was the addition of the launch escape system. So we needed a way to protect the astronauts in case something happened to the booster on a set. So we basically needed to add what's called the Super Draco engine to the exterior of the vehicle such that at any given point from on the pad all the way to orbit, we could successfully, effectively eject the astronauts off that booster. And, so that was sort of key upgrade number 1. Key upgrade number 2 is the addition of the life support system. And
I was going to say, it's got to be the potty. Like, upgrade 2 is like, you got to have the potty.
It's all of the things you need to make people comfortable and sort of provide that cockpit environment. The seats, the suits, the various displays, the pod, the bins to keep the stuff, right? The stuff that's required to actually put the pilot in the loop. Really, the last part isn't a big upgrade, but we learned a lot on Dragon 1, and we made sure to roll all of those sort of lessons learned into the space.
As far as the Falcons go themselves, is there something special other than just that cognitive understanding of like this one's going to fly through? Is this the same as the other Dragon cores that are here or in process for the
Falcon cores, I think you were.
Yes,
Dragon core.
whatever I said. Forgive me. No.
Yeah. Fundamentally, that is also one of the things we highlighted is we didn't want to make this booster different than the 74 other ones we've flown, right?
Sure.
We wanted it to be consistent. We wanted to prove out that very reliable launch operation, in the way that we load the rocket, the way we fly it. So it's not inherently different than the other Falcon 9. This is a new Falcon 9 in front of us, specifically the first Falcon 9 that we'll ever put a person on top of. So in a lot of ways, that's what makes it special.
Yeah.
And so while the hardware itself is new and shiny and has beautiful logos that help signify, this partnership between SpaceX and NASA and make us proud as Americans, I think when I look at it, I actually think of all of the hours and years that have gone into an incredible amount of hard work and engineering between SpaceX and NASA to certify a rocket for human space. There is zero doubt in my mind that in the majority of in all of SpaceX's mind that we would not be here today, we would not be standing where we are today if it wasn't for that partnership.
Is there a moment for whether it be the Falcon or the Crew Dragon where you pause for a second, you're like, wait a second, like this one's going to have people. Like, is there a moment? Is there extra attention to detail, or is it just like, hey, we're going to do great work like we always do? Let's go.
Yeah, I mean, it is absolutely critical for us that every mission that we fly has the utmost reliability. But I don't think it would be fair for me to pretend like we do not all realize the gravity of what is in front of us.
Very good. We'll keep going. Appreciate you. It's been phenomenal. Obviously, we're all excited. I'm ready to see humans fly again from America, and that's happening very, very soon. We're excited for you guys. Awesome. And for us and for all of America, so we're ready to go.
So are we. Thank you.
Let's do it.
All right, so we are joined here with Mr. Joshua Santora himself. Joshua, you know, the people who are watching the social, they know you as the NASA guy.
Sure.
But can you tell us a little bit about your role with SpaceX and the Commercial Crew Program and what it's been like for you to be a part of this?
Sure, yeah, I want to just be clear up front and say I'm not a SpaceX employee. I'm not going to speak for SpaceX. That's not the role of those that work in NASA communication. But ultimately, we work right alongside them. And that's been a big part of this process of working beside the team at SpaceX. Partnership is the right word. With historical programs like the Space Shuttle, NASA controlled that information. We controlled the process. We controlled the vehicle. It was NASA's and we owned it. And that's not the case with this. And so there's been a learning curve involved. And we'll talk, I'm sure, some more about that today. But just excited to be here and answer questions that people might have. Ultimately, again, I don't have the insight of a SpaceX employee, but have had the chance to work with them on a lot of projects, as we saw earlier today with some of the 360 video stuff. We'll see that again tomorrow morning, this video. And I've been over that way a few times and worked on different projects with them over the years. So excited to be a part of this picture, a part of this mission, a part of what's happening, and ultimately just working with them through this process.
For sure. So let's hop right in. Stephanie, do we have any questions from online?
Yes, we have a few great questions for you, Joshua. So here's one from Yuri. He wants to know, why was the Falcon 9 and Crew Dragon erected at LC-39A versus stacking it up right at the VAB and transporting it out to the pad?
Yeah, so this is fun, and we heard Regina Spellman talk about this when it comes to the fashionability of architecture with rocketry. And this may not be quite the same thing, because she was referring to things like clean pad and then fixed pad structures. But this is similar, where companies decide to do things different ways. And so we have lots of companies, and actually, Philip, you can probably speak to this some too, because the Launch Services Program, they experience this with different partners of how they operate and process. And so I'm sure there are some technical reasons, but I think that there are probably pros and cons to both of those. And so SpaceX, they decided that they wanted to put their vehicles right there near the pad so that they could go out and come back quickly. Obviously, if you watch Rollout this past week, if you watch kind of that vertical tip, you know that they can do this in a matter of a few hours. It's a very speedy process. Whereas NASA, with us working in the vehicle assembly building, we have to take at least a full day to make that trip out to the launch pad. And now there's, again, pros and cons to both. With the vehicle assembly building, all of our hardware is very far from the launch pad, where your fueling's happening, and so we're distant from that. With the SpaceX concept, with the hangar being there, like they're closer to their fueling, and they're closer to the rocket when it's armed. And so ultimately, again, pros and cons, and that's just the way they decided to do it. That's their architecture. So Philip, I don't know if you want to add any more. Again, just curious to know your perspective on this.
Right, that's a really good connection that you drew between the different decisions that the launch vehicles make for human spaceflight. The same thing happens for robotic scientific missions as well. So for the Launch Services Program, we only work with the robotic missions. So, but it's the same thing. There's a lot of overlap between the companies and the programs. So we have to make sure that our spacecraft customers, and NASA's people who build the spacecraft, that they are able to adapt to those different environments. Because when they say, hey, LSP, can you get us a rocket? We need to make sure that the rocket is able to meet the needs of the spacecraft. So if the spacecraft can go horizontal before launch, great. If it needs to be vertical, we need to work that problem. So it's really interesting with such an evolving launch vehicle market. New companies coming up and new vehicles is really exciting, and it introduces a lot of new challenges. But it's really exciting, and obviously it drives the market to a better place where we have better options and things are cheaper and much more affordable. So
and also just kind of sampling some other of the companies around. We have the launch pad here, Launch Complex 41 is where the Atlas V launches from, and they actually they bring theirs in horizontally and then stack it in a vertical integration facility and then roll it out to their pad. It's not quite as far as a VAB trip to pad. And then we have the Delta IV pad 37. They actually stack it. They do the same thing. They build it. They stack it vertically in the building, and then they roll the building away. So just different options. And then we have newcomers, Northrop Grumman. They're operating out of the vehicle assembly building, and then Blue Origin. I'm not quite sure what Blue Origin is doing yet. I haven't seen much publicly from them, but they're building a lot around here right now. So I'm anxious to see them really begin flights from the Space Coast.
Right. I'm glad you brought up the Delta IV Heavy because before the Parker Solar Probe launch a couple of years ago, I sat in a parking lot where I could see the building, and I did a little time lapse of seeing the building just crawl back. So that was a very cool thing to see.
Yeah.
Pretty unique here on Center. So, yeah.
All right, so we have another question from our Facebook community, and they want to know, was this Falcon 9 booster used on any other previous missions, or is this its first mission?
Yeah, good question. And this one is a brand new booster. So obviously there we saw, and Kiko kind of alluded to that, this being a shiny new booster. And if I'm not mistaken, I believe that in the contract that SpaceX had with NASA for this is that they had committed they would be using brand new boosters for their flights. And so we've seen SpaceX time and time again use flight-proven boosters is the term that they love to use, and that makes a lot of sense. We've seen that happen a lot, and that may happen at some point, but for this point in time, they're using brand new boosters. And so excited to have a brand new Crew Dragon, a brand new Falcon to take Bob and Doug to the space station tomorrow.
So Joshua, I'm going to ask you a question that we've asked a lot of our guests. Obviously, tomorrow is a big day for America as a whole, as well as NASA and SpaceX. So where are you going to be watching the launch from?
Yeah, so I will actually be out at the press site. So if you're familiar with the countdown clock, we featured that yesterday on one of our shows. I'll be out there. I'll helping support media activities. There's a lot going on. We do have some media out because they're a huge part of our story as well. They're a part of what we do and how we do it. NASA is charged as part of its mission, as part of its goals, is to disseminate as widely as practicable what we do. That includes everything from science research to launches to space station activities. And so the media are a major part of that, where they actually help carry the story for us. So we are excited to have them. We are glad to have them. We welcome them. Certainly, this current environment, we're limiting the specific numbers just for the sake of health and safety. But that aside, we love to just have as many people as we can, really helping to be a voice telling our story with us.
I want to hop on that a little bit. So I'm from Texas originally. I've only lived in Florida for about 3.5 years. So I was never here when the space shuttle flew. So I've been here on an exciting launch day, but never for a human launch day. So can you describe, for me and for anybody else who's never been, in Florida, at the Space Coast for a human launch, what the energy feels like? And what it's like to anticipate.
Yeah, and I have it in mind. I have a couple photos from STS-135, the final flight of Atlantis, final shuttle flight Atlantis. What a beauty. And they're really fun photos because I was in the process of putting on a show similar to this for educational purposes, where we were actually out on the press site lawn. And so I actually have a photo from there. I got to see that one from there. That one was that one was on another level. There's exciting launches, and then there's STS-135. And it's tough to kind of explain that to people, and most of the terminology and the way I describe this feels very cliche, and I own that. I own that it sounds cliche, but I still say it, explain it this way because it's the only way I know how. Is that working here in the shuttle program? I was here for the last 2.5 years of the shuttle program, and it's amazing how connected you feel very fast. I was working in our education department at the time. Certainly I wasn't the one turning wrenches. I wasn't the one pushing the button, so to speak, but felt a part of that, and that I felt like a part of that team and a part of that family. And so there was like this, it is an indescribable energy of like we're doing this together. And so to know there's crew on board, like I think whenever you see the crew drive by, that's like the moment when you're like, whoa, because tomorrow afternoon we're going to see Bob and Doug roll by in a Tesla that's got some beautiful NASA emblems on it, and they're on their way to the pad. Right. And so that's a moment when you're like, man, like they're going to strap in on top of that thing. Right. So it is exciting to see a rocket launch. It is unbelievable to know that there's people that are strapping themselves in and making that trip into space.
Right.
It's fun.
Awesome, thank you, Joshua. We have another question from our Facebook community. They want to know, will the Falcon 9 booster land back once it puts Crew Dragon into orbit?
Yeah, so this one, and so the question there becomes for the Falcon 9 in general, their performance capability. And so we know that we've seen them land here at Landing Zone 1, which is at the Cape Canaveral Air Force Station. We've also seen them land on their barge out in the Atlantic Ocean, roughly kind of directly off the coast of Jacksonville a ways. And so a lot of that decision comes down to how much fuel do they need to get their payload where it needs to go. That's always job one, is get the payload to its intended orbit. And so once the first stage is done, that's the decision point. And they make this decision way before that moment in time. But that's where the booster has to have enough fuel to return and fly back, or it has to just continue going towards the barge. And so essentially, if you kind of, and this is obviously very simplified, but essentially it launches more on an arc trajectory because it doesn't fly straight up. It flies to go rendezvous with space station. And so once it flies this direction, essentially, in order to come back to KSC or to the Cape Canaveral Air Force Station, it has to have enough fuel to actually stop its momentum, turn around, and then fly back and land safely. That's not a tiny amount of fuel. You need a good bit left there. So if they don't have that, then what they do is they simply just kind of go into, and it's not a free fall. It's very precise. They have their hypersonic grid fins and their landing legs, so they're doing a lot of maneuvering here, but they're going to more fall back towards where the barge will be located. So the barge is kind of a catcher's mitt of sorts. They position it where they know that that booster will come down, where they have enough fuel to land safely, but ultimately they don't have enough to return to their launch site.
Well, Joshua, we can probably update your tagline from NASA Communications to Launch Vehicle Trajectory Analyst, because clearly you get it.
Is that what you do, Philip? Am I ready? You're getting ready to put me in?
That's exactly what I do. I use my hands and I say,
perfect.
Yes, exactly. So that was a great description.
Yes, I love it. I'm in.
All right, Joshua, I think we have time for one more question. And we want to know, what does it mean to you personally to have human spaceflight return to the United States?
Yeah, such a good question. And I think that there's a sense to where I've heard it answered a couple different ways, and I think all of them are really valid. The first is that there's this inherent drive in humanity to explore, and I think that is something that this moment connects with a lot of people. That you don't have to be the one hopping on that boat to cross the Atlantic for the first time. You don't have to be the one hopping on that rocket to fly into space. You don't have to be the one trekking across America and over the plains and over the Rocky Mountains. There's something about that that's really just captivating. We saw this with the moon landings. People stopped and took notice around the world. Everybody did, and everybody kind of owned a piece of that, of like, we did it. We've accomplished this. And so there's that's really important. I think that there's a sense to where it's just achievement. It's just, hey, like, we have this ability. We're ready to move forward. There's the desire to kind of expand beyond, of like, we know this is a stepping stone with which we will go farther than we have before. And I think that's really powerful. And then there's other things for people who don't connect with those ideas. There's things that I would encourage them to think through, of like, when we do anything, NASA, one of the things that happens is called spin-off technology, where we actually create things. We create brand new things to help us achieve our goals. We heard Jim Morhart earlier today here, sitting in this seat, talking about in situ resource utilization, which is living off of the moon's resources. And so we will invent technology to live off the resources of the moon. And that technology will not be used just for that. We will export that technology to commercial companies on Earth. Now, obviously, they may or may not go to the moon, but there are other applications for that technology. People oftentimes will cite some popular examples. Velcro is a common one. That's not actually invented by us, but that's kind of the idea there, of like, when we use it, we develop it and export that technology for others to benefit. And that's what we mean when we say the benefit of all mankind. That's a part of that. So the cell phone that you keep in your pocket, that cell phone would not be anywhere near as amazing as it is today without NASA. We have helped drive forward communication. We've helped drive forward battery technology. We've helped drive forward GPS and satellite systems. And so all of those things kind of come together. That's just one example. There's everything from your sneakers to your tennis rackets to infrared technology. I mean, even in your house, there's dozens of things today. So just encourage you all to think through those. For me personally, I think that I get captivated in being a part of something bigger than myself. Of just, this is something that we can achieve together. And despite the challenges, despite setbacks that happen, despite the things that keep us from getting there today, immediately now, those are the things that make it worth it, right? We get to overcome and triumph. So those are the things that come to mind. But I think that last one is really where I'm at. Of just like being a part of something big is a pleasure and a joy. And I hope that all of America will feel that tomorrow as we achieve this for America and for all humankind.
That's really great. That's awesome. And I'm glad you mentioned, the technology and the applicability of all these things. I think NASA spinoffs is a way that people can learn about, the ways that the things that NASA is doing, it doesn't stop at where we are going. So, and I think just personally for me, I'm so excited for the launch because, as I said, I've been here for 3 years, and I've actually been tallying. I've seen 40 launches, which is unbelievable.
Awesome.
Like 3 years ago, I had seen 0, and now I've seen 40 launches, and every one has been just a little different. There's, just something unique about each launch, and tomorrow it'll be like, wow, there's people on there. Like I model this rocket all the time, but there's people on that one, so that I'm really excited to see that. So. Joshua, thank you for your comments, all the information, and for being here with us. Hope you had a good time.
Yeah, last thing, just want to give a huge shout out to the communications teams for both NASA and SpaceX. They have been laboring for years, working through challenges, learning how to work together, and achieving a ton. And tomorrow is going to be another big accomplishment as we do the launch broadcast side by side, telling this story together.
Awesome. Yeah, definitely congratulations to everyone who's been working on this. And yeah, Stephanie, thank you for being a part of this as well.
Thanks for having me.
And thank you all for joining us. We hope you continue to be a part of these NASA socials. Next up at 4 o'clock Eastern, we will be having a couple more pop-in speakers. So please join us for that. And until then, we will move on forward towards launching America.